Peter, hi.
Yeah, good to see you.
Good to see you.
Yeah.
Thank you. Thank you for doing this with us.
Welcome
Pleasure
to
meet you.
Parkville, the thriving heart of Melbourne, as it was about 1910. Good.
Peter, I'd like to introduce my staff member, Sarah.
Hi,
Hello,
how
Sarah.
are you?
All right.
Nice to meet you.
And she'll be joining us for the little ride along that we're going to do. Peter,
Great car.
welcome to the shitbox.
Wow, lovely advertising too.
These are some of our sponsors from a charity road rally that we did earlier this year.
Yeah, this must make you enormous amounts of money having that on the side of your car.
You can't imagine
Well, it's
how
all
much money.
Cancer Council research.
It just floods in homes.
Yeah.
You want to be in the front or the back?
No, you're a guest of honor. We welcome you to the front seat here. Yeah, please. So what is it like having your own building?
Sure. What is it like? Well, it's a kind of a bit weird, really. You're really, usually people are dead by the time they get in the building. So there's a bit that sense you want to get over into one of those.
So your building is right up there?
Yeah, that's right, on the right there.
You have your own logo as
It's
well.
got a logo up top. It's,
Did they consult with you on the logo design?
I told them not to consult with me on anything. I didn't want to have any influence on the way it was done. I think old guys should stay out of the thing. The only thing I was very keen on is that, so far as possible, they kept the labs generic so they'd be flexible. And that they did, except for some of the specialized floors where we have, for instance, the Vidral, the virus diagnostic, state labs.
Did you get first pick of the offices?
No, I just went where they told me. I'm the patron, which means you have no power and you just do what you're told.
Right.
When you're told to do it. So. But it's a good building. It's very good environmentally. The brown color you see on the windows there is due to the fact that it's between the double glass and the double glazing, they've got wooden slats. So it's a wonderfully energy efficient and heat efficient building. And with all this construction going on outside my window, I don't hear anything.
Wonderful.
Yeah.
And how often are you in the office these days?
I'm nominally working 3 days a week, but I'm actually working less. I'm going to 1 day a week soon. I was going to retire completely, but they suggested I should keep on at 1 day a week, which is about what I do for the university now.
Okay.
And otherwise I'm trying to retire, but I'm failing retirement at the moment, and writing.
Are you working on another book?
Yeah, I'm working on, I've done 6 books since 2005. I've published 6 books on basically science or the scientific life.
Yes.
And now I'm doing the first book that's not science, which is basically a book on war and tennis.
War and tennis.
And tennis.
Okay.
Okay.
It's based on the stories of my 2 uncles who were sort of good local tennis players.
Right.
Went off to World War II. One came back, one didn't. And if you go...
Yeah, I think if I cut over here.
Come back for a year after the traffic light. And the one that didn't come back was in Malaya for 10 months before the Japanese attack. You know, they attacked Malaya, the Philippines, Hong Kong, and Pearl Harbor all on the same day, essentially. And so he was there for 10 months before that, which was kind of a phony war period.
Yes.
And during that period, he wrote some 30 letters. We've got some 30 letters from him. So the book is expanded actually to be a book on war and tennis and imperialism. So it's getting even more complicated.
You seem to be very interested in history in general and sort of all the side anecdotes of...
Well, I'm to some extent I am history because the world we grew up in as kids. Yeah. Which is, Australia did not have television until 1957. And that was a key factor in my life because I was born in 1940. So I was 17 years old before we got television.
Right.
And so the life that I grew up with was not that different from the life that my parents grew up in the 1920s and 1930s.
Yeah, of course.
And and it's gone now. I mean, really, really gone.
So let me ask you, Peter, is this the most unusual venue or type of interview that you've done?
Driving around the car. Yeah, basically, I've been shortly after the Nobel Prize, people were taking photographs. Every photographer is trying to take a unique photograph.
Right.
So you sort of find yourself perched in precarious places, or with paddle steamers in the background because we're in Memphis, Tennessee.
Or perhaps on a very small horse.
That was an aberration. We were in Kunming, up in the Himalayan foothills on the Chinese side.
Right.
And they offered us a post-conference tour along with the opportunity to go horse riding. And very foolishly I accepted. And I wrote a chapter in the latest book I wrote, The Incidental Tourist, about how I made a complete fool of myself on a horse. And of course they said, we have to have a photograph.
It's a great photo.
And I denied all knowledge of the existence of a photograph, but my wife produced it.
I have to say that when I've shown that picture to people I know, they always react, he's either a very tall man or it's a very small horse.
It's a very small horse. It's basically a little mountain horse. You know, there's an incredible horse culture in that part of China. This used to be the horse abattoir. That's where the old veterinary research institute, that is the old veterinary research institute.
That's where I did my PhD.
Oh, right, okay.
Yeah, with Professor Wayne Kimpton.
Okay.
Yeah.
So a horse abattoir for the horses that didn't make it, or...
Well, you know, we had a horse transport system.
Right.
So there was a horse knackers. I mean, the horses had to be killed.
Right.
And disposed of at some
large.
time.
One thing you never really think very much about it, how many horses...
Oh,
you know,
yeah.
you have junkyards for cars, but back in those days you had to dispose of a lot of horses.
Well, it was easier to dispose of horses. I mean, they degrade, but there was a hell of a lot of horse shit in the street. I mean, people forget these things. They forget that nobody had deodorant.
Well, I guess the horse shit in the street is a form of deodorant. You can't...
I mean, some of these houses, if you just go slowly past this lane, you might see it. But some of these houses, you can still see there's a little bricked up, what was a door in the fence back on the lane where the night cart came and picked up the big cans of crap.
Uh-huh.
And so the toilet was always outside.
Yeah.
And right at the back of the house. And it didn't matter how rich you were, that's the way it was.
Yeah. On the way here, I've been getting all of these waves and from people, and I thought, oh, you know, I must be dressed.
But they don't people here don't like to think of this sort of car in this neighborhood.
No, they're just actually looking the other way.
They look the other way. They'd rather not know.
But it's the car. It's not me. I keep thinking they're waving to me, but no, they're noticing the car. Or they, I thought maybe.
We all make these ridiculous assumptions. I mean, I used to make the assumption that when young women looked at me with somewhat dewy eyes, they were interested in some sense, but I know it was just badly fitting contact lenses.
It's a pleasure to be here with you, Peter Doherty.
Nice sitting out here in the park.
We're lucky with the weather today.
Royal Park is where Burke and Wills left from some years ago.
On their ill-fated mission, I guess.
Definitely ill-fated.
Yeah. Peter Doherty, what are you best known for?
Well, I'm best known for the discovery we made way back on what's called the killer T cell, one of the categories of white blood cells. You know, we've got red cells and we've got white cells, and they go around our blood, and there's a lot more red cells than white cells, but the white cells have got various specialized jobs to do. And the one we were studying was called a T cell, and it's a killer T cell. It's a cell that goes around the body and it kills off other cells. It's a hitman, it's an assassin. And and the cells it kills off are the cells that have gone wrong. We have to get rid of them. This is going on all the time in us, and we're totally unconscious of it. So one of the categories of cells that would have to kill off is a cell that gets infected with a virus. You know, viruses aren't like bacteria. Bacteria can grow in culture medium, or they can grow in water or on soil, but viruses can only grow in living cells.
Right.
So the viruses that infect us get into our cells. Say an influenza virus comes in by the throat, gets into the lung cells, grows in our lung cells, and it will destroy that cell ultimately. Now, the killer T cell is designed to come in and bump off that cell. Now, you say, why does the body care whether the virus kills the cell or the killer cell kills the cell? Well, it cares because the killer cell will kill the cell before it produces more virus particles and infects more cells. And so that's what we were working on, and we discovered that the reason those killer T cells focus onto cells is that they recognize a modification of a protein that's on the surface of a cell. They ignore it if it's normal, but if it's carrying a little bit of the virus, they'll kill that cell.
Right.
And that's what we won the Nobel Prize for. The discovery was made way back 1973, 74, and we got the Nobel Prize 22 years later in 1996.
Right. Amazing. Can you briefly describe the experiment that you did?
It was an experiment where we were looking at a virus infection, and we were looking at the capacity of these killer T cells, which we could take out of the body, put them in a little tube, and kill cells we'd infect with virus. And we found that they would only kill the cell with the protein that's in the individual that the cells came from. It's called the major histocompatibility complex proteins. These are the proteins that are recognized in graft rejection. You know, we're all different from each other, and you know, if we transplant a kidney from one person to another, it'll be rejected unless we use drugs that suppress these T cell responses. But that's what those proteins are about. They're not about trying to frustrate transplantation. They're there to mark that a cell is changed in a way that needs to be eliminated.
Right.
A lot of my career really in science and writing is about trying to make unexpected linkages.
Yeah.
And once you make that linkage, trying to explore it. So, you know, as I was telling you, I'm starting to write a book about my first non-science book, about war and tennis based on the story of my two uncles. But then I realized that also what happens with those wars, the whole war in the Pacific and World War II, it's about empire. I mean, the war in the Pacific for America is partly about the Spanish-American War. Because in the Spanish-American War, America took the Philippines and it took Guam. So suddenly it's a major Pacific power. Okay, so even though it's not actually treating them as colonies, they're still American.
About preserving the empire.
So as Japan is trying to, Japan wants to knock off the British Empire and the Dutch Empire and the French to the south. Well, the Nazis knock off the French, and French Indochina becomes Vichy and sort of pro-Japanese. But then they want to get rid of the British and the Japanese, but now they have to worry about the Americans. And so the Philippines are very close. So, you know, you can think to some extent the fact that America came into the Second World War reflects what happened in the Spanish-American War.
Very interesting.
So I'd never thought of it in those terms before, but in thinking about that, I mean, you know, really the whole of what happened in Malaya, Indonesia, Burma is all about Japanese imperial ambition. I mean, they wanted to control the rubber and the oil, and they wanted to get rid of the European imperialists.
I might just ask you about this because I noticed that this seems to be, I've read a few of your books, and this seems to be one of the characteristics of them, that you draw these linkages between places and things. Is that also your scientific superpower, so to speak, the ability to draw connections?
Yeah, no, that's what I did in science. I tried to draw connections between different things. And working with viruses in the immunity field, which early on nobody did almost. There were very, very few people working. Immunologists weren't working with infection. We made it much more fashionable to work with infection. And the good thing about infection, of course, because infections are complex, and they throw up things that you don't expect. And so you don't get into a kind of purely linear thinking mode. You're always being surprised by something that comes in from left field. And of course there's enormous complexity we understood nothing about when we were doing those early experiments.
So for the non-scientific people listening to you describe your Nobel Prize-winning research, how do you explain it to the layperson?
Well, you know, some of these new cancer therapies where people suddenly they're given a drug and their cancer melts away. Doesn't work for everyone, it works for some people. They're due to the fact that there are white blood cells. You know, we've got red cells and white cells in our blood. There are white blood cells that go around in the blood, then go into things like tumors and so forth, that they're actually capable of getting rid of that tumor, but they're switched off somehow. And they're what we call the killer T cells. These are cells that are programmed to kill other cells. Well, my friend Jim Allison just won the Nobel Prize for working out how to wake those cells up in the tumor so that they bump off the cancer cells. And so that's the Nobel Prize for 2018. Okay, so much earlier, way back in 1996, we got the Nobel Prize, the other Nobel Prize, for these killer T cells, these white blood cells that bump off other cells. And we got the Nobel Prize because we made a big discovery. What we discovered was that these killer T cells, who are there to bump off cells that have gone wrong, like cancer cells or virus-infected cells, the reason they recognize a cell's been changed in some way, so it's now a bad cell, as distinct from a good cell, is because there's a change on the surface of those cells in what's called the transplantation proteins. And these killer T, we discovered that these killer T cells recognize that, say, that a little bit of, say, the cancer is in the tip of that transplant molecule, and that tells our killer T cell to bump that cell off. We can't have cells going around the body that bump off normal cells, because that would be a disaster. Only the bad ones. And we were working with a virus. Now, viruses are organisms that have to grow within living cells. So they'll get into our own cell. The influenza virus will get into our lung cells, grow in those cells, and make a lot more virus. And you've got to stop that process, because the infected cell is kind of a factory. And what the killer T cells do is kill off those factories and stop the virus from spreading within us. So they're very important in bringing an infection to an end.
Peter Doherty, thank you for joining us for Scientists in a Shitbox Spelling It Out. I have to ask you one last question.
Yeah.
Do you need a ride home?
It's been really nice sitting in this bench, and that car does not smell good. So I'm quite happy to walk home unless you want to get the last video footage. It's not very far from here, and it's fresh air. I mean, you know, you need to deodorize that car.